Hello students, how are you all? I hope you will be fine and doing your best to study in this pandemic period. So today's topic is from your plus 2 chemistry, chapter electrochemistry, and the topic is electrolytic cells, electrolysis and Faraday's laws. So first of all, let's discuss what is electrolysis. It is a process of decomposition of an electrolyte by the passage of electricity through its aqueous solution or molten fused state, and the setup used to bring about this decomposition of an electrolyte by the passage of electric current is known as electrolytic cell. One of the simplest electrolytic cell consists of two copper rods which are called electrodes dipping in an aqueous solution of copper sulfate which act as an electrolyte in a suitable vessel called electrolytic tank. When electric current is applied to the two electrodes, the electrode which is attached to the negative terminal of the battery act as cathode, and the electrode which is attached to positive terminal of the battery is called as anode. When the electric current is applied, then copper ions discharge at the cathode. That means copper ions carry 2 unit positive charge and they travel towards the negative electrode, that is cathode. So copper ions, by gaining 2 electrons, changes to copper solid, and the copper metal is deposited at the cathode. At the anode, copper is converted to copper ions. As we all know, at anode oxidation take place. So here solid copper metal, by losing 2 electrons, changes to copper ions. Thus copper is dissolved at anode. In terms of oxidation and reduction, we can say copper is oxidized at anode while it is reduced at cathode. This is the basis of an important industrial process in which impure copper is converted into copper of high purity. This is one of the important method of metallurgy. For example, sodium and magnesium metals are produced by the electrolysis of their fused chlorides, and aluminium is produced by the electrolysis of aluminium oxide.
Let's study the process of electrolysis by doing an activity. Take a glass of water. In this, we use copper sulfate as an electrolyte, which is blue in color. Dissolve the salt in water to make a clear blue solution of copper sulfate. Mix it well. The electrode which is attached to positive terminal of the battery is called as anode. Here we use copper rod as anode, and the electrode which is attached to negative terminal of battery is called as cathode. We use iron safety pin as cathode. So the blue color of solution is due to copper ions. So in the process of electrolysis, the copper ions move to negative terminal of battery and deposit on the safety pin. Dip the two electrodes in copper sulfate solution. and switch on the current source. Now observe the changes taking place. The copper rod starts dissolving at anode. So here oxidation takes place and the copper ions from the solution move towards cathode and gets reduced there. The black colored floating particles are the impurities. After some time, switch off the current source and check out the safety pin. You will notice a brown colored coating of copper on the safety pin.
Now let's discuss Faraday's laws of electrolysis. So the definition of Faraday's first law of electrolysis is, it states that the amount of any substance deposited or liberated at any electrode is directly proportional to the quantity of electricity passed through the electrolyte. So if small w gram of the substance is deposited on passing q coulombs of electricity, then according to Faraday's first law of electrolysis, W is directly proportional to Q, or W is equal to Z into Q, where Z is the constant of proportionality called as electrochemical equivalent. If a current of I amperes is passed for T seconds, then the quantity of electricity Q is equal to the product of current and time, that is I into T, so that W is equal to ZIT. Now if Q is equal to 1 coulombs, or we can say if 1 ampere of current is passed through an electrolyte for 1 seconds, then W is equal to Z, that is electrochemical equivalent. Hence, electrochemical equivalent of a substance may be defined as the mass of the substance deposited when a current of 1 ampere is passed for 1 second. That is, a quantity of electricity equal to 1 coulomb is passed. Let's understand the Faraday's first law of electrolysis by taking one example. During the passage of electric current through molten sodium chloride, sodium gets deposited at cathode and chlorine is liberated at anode. So during the electrolysis of NaCl, it gives solid sodium plus half chlorine gas. During electrolysis, sodium ions move towards cathode and accept electrons and get deposited at cathode. So Na positive ions in aqueous state plus electron changes to sodium in solid state. So let me explain the different aspects of this reaction. Here, one sodium ion by gaining one electron changes to one atom of sodium. And if we can say Avogadro number of sodium ions by gaining Avogadro number of electrons changes into Avogadro number of atoms of sodium. Or in other words, as we know, Avogadro number of entities is equivalent to 1 mole. That means 1 mole of sodium ions by gaining 1 mole of electrons changes into 1 mole of sodium atoms, or we can say 23 grams of sodium, because 1 mole is equivalent to the gram atomic weight. So if we have to find out the charge on 1 mole of electrons, then we have to multiply the Avogadro number of electrons with the charge of 1 electron, that is 1.602 into 10 raised to the power minus 19 coulomb. This value comes out to be 96500 coulombs, or we can say 1 Faraday of charge. So we can say that 1 Faraday charge can deposit 23 grams of sodium on the cathode. So according to Faraday's first law of electrolysis, the amount of substance deposited on cathode is directly proportional to the quantity of electricity passed. So here if we increase the charge to 2 Faradays, then the amount of sodium deposited becomes 2 into 23 gram, that is 46 gram of sodium. Similarly, at anode, chloride ions give up electrons and produce chlorine atoms, as 2Cl negative aqueous changes to chlorine gas by losing 2 electrons. So it is clear that one molecule of chlorine gas is produced by 2 electrons, or half molecule of chlorine or one atom is evolved by losing 1 electron. In other words, we can say that Avogadro number of chlorine atoms is produced by Avogadro number of electrons, or we can say 1 mole of chlorine atom is produced by 1 mole of electrons. That means here 35.5 gram of chlorine is produced by passing 1 Faraday of charge through it. Now let's discuss Faraday's second law of electrolysis. It states that when same quantity of electricity is passed through different electrolytic solutions connected in series, the weights of the substances produced at the electrodes are directly proportional to their chemical equivalent weights. So let's understand by taking an example. Consider an experiment in which same amount of current is passed simultaneously through two different electrolytic solutions. For example, silver nitrate and copper sulfate as shown in figure. In first cell, at cathode following reaction takes place. Here, silver ions by gaining one electron changes to silver solid. That means 1 mole of electrons produces 1 mole of silver atoms, or we can say 1 Faraday of charge, that means 96500 coulomb of charge produces 107.87 gram of silver, which is the gram atomic weight of silver. So as we know, the equivalent weight of silver is equal to atomic weight divided by the number of electrons gained or lost, which means in case of silver it is 107.87 divided by 1. That comes out to be same 107.87 gram. In second cell, at cathode following reaction takes place. Copper 2 positive ions by gaining 2 electrons changes to copper solid. That is, in this case, 2 moles of electrons are responsible for the production of 1 mole of copper solid. Or we can say 2 Faraday or 2 into 96500 coulomb of charge is responsible to produce 63.5 gram of copper, which is the atomic weight of copper. If we fix the quantity of electricity to 1 Faraday, then in case of second cell, 1 Faraday or 96500 coulomb of charge produces half the weight of copper. That means 31.77 grams. As we know, equivalent weight of copper is equal to atomic weight divided by the number of electrons gained or lost. That means 63.54 divided by 2, which comes out to be 31.77 gram. So thus, when same quantity of electricity is passed through different electrolytic solutions connected in series, the weights of the substances produced at the electrodes are directly proportional to their chemical equivalent weights. However, in modern terms, the term equivalent weight is not used. The Faraday's laws of electrolysis in terms of moles of electrons exchanged may be stated as the amount of chemical change occurred, that is, the moles of substances deposited or liberated, is proportional to the number of moles of electrons exchanged during the oxidation reduction that occurs. Thus, from the knowledge of moles of electrons required during the electrode reaction, the amount of substance deposited or evolved can be calculated. For example, in the reaction, aluminium 3 positive ions by gaining 3 electrons changes to aluminium solid. So here 1 mole of aluminium ions by gaining 3 moles of electrons produces 1 mole of aluminium. Thus, 1 mole of aluminium will be deposited by 3 moles of electrons, or we can say 3 Faradays of electricity, which is equal to 3 into 96500 coulombs of electricity. Similarly, lead 2 positive ions by gaining 2 electrons changes to lead solid. Thus, 1 mole of lead will be deposited by 2 moles of electrons or 2 Faradays of electricity. Therefore, by knowing the amount of electricity passed, we can easily calculate the number of moles of products formed from the particular electrode reaction. And from the moles of the products formed, we can calculate the masses of the products or their volumes if they are gases. Therefore, the amount of electricity needed or amount of products formed can be calculated from the electrode reaction. So, you have to learn how to write these reactions, then you will be able to solve the numerical problems related to Faraday's laws of electrolysis. Let's try to solve some numerical problems. So first is, a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at the cathode? So here, in this statement, the amount of current is given, that 1.5 amperes, and time is also given, that is 10 minutes, or we can say 600 seconds. The quantity of electricity passed, Q, is the product of current and time. That means 1.5 ampere into 600 seconds, which comes out to be 900 coulomb of charge. So here in this numerical, copper is deposited as copper ions by gaining 2 electrons changes to copper solid. So that means 2 mole of electrons or 2 into 96500 coulomb of current deposit copper is equal to its gram atomic weight, that is 63.56 gram. So 900 coulomb of current will deposit how much copper? 63.56 divided by 2 into 96500 multiplied by 900, which comes out to be 0.296 gram. Let's solve one more numerical. How many coulombs of charge are required to deposit 40.5 gram of aluminium when the electrode reaction is aluminium 3 positive ions by gaining 3 electrons changes to aluminium solid? So from the reaction, clear that 1 mole of aluminium requires 3 mole of electrons or 3 into 96500 coulomb of charge. As we know, 1 mole of aluminium is equal to 27 gram, that is its gram atomic weight. So 27 gram of aluminium requires 3 into 96500 coulomb of charge, and 40.5 gram of aluminium requires how much charge? By putting the respective values, it comes out to be 4,34,250 coulomb of charge. So here comes another numerical. How many coulombs of electricity are required for the following? First is oxidation of 1 mole of ferrous oxide to ferric oxide. Second is oxidation of 1 mole of hydrogen peroxide to oxygen gas. Third is reduction of 1 mole of fluorine to fluoride ions. In first case, the oxidation reaction of ferrous oxide to ferric oxide is, we have to write the reaction ferrous ions, that is Fe2 positive ion, by losing 1 electron changes to ferric ion, that is Fe3 positive ion. So from the reaction, it is clear that 1 mole of ferrous ions are oxidized by 1 mole of electrons, that means 1 Faraday or 96,500 coulomb of electricity. In second case, in the oxidation reaction of hydrogen peroxide to oxygen, the reaction is the peroxide ion, that is O2 negative ion, by losing 2 electrons changes to oxygen gas. So here 1 mole of peroxide ions are oxidized by 2 mole of electrons. That means here the charge is equal to 2 Faraday or 2 into 96,500, which comes out to be 1,93,000 coulomb of charge. In the third case, in the reduction reaction of fluorine to fluoride ion, the reaction is fluorine F2 by gaining 2 electrons changes to 2 fluoride ions. So from the reaction, it is clear that 1 mole of fluorine is reduced by 2 mole of electrons, or in terms of charge it is 2 Faraday or 2 into 96,500, that means 1,93,000 coulomb of electricity. So try to solve one numerical which I have given to you and post your answer in comment section. If you have any query related to this topic, please post in the comment section. If you like my video, then please subscribe my channel and click the bell icon for further updates. Thanks for watching.